All right, hello and welcome to today's class where we're going to look at WEBGL in p5.js and then talk a little bit about once we make something using WEBGL in p5, what can we do with it after? So what does WEBGL stand for? It's Web Graphics Library. So this library was built for website compatibility, and it's a JavaScript API. API being Application Programming Interface. So WebGL can be used in any software that uses JavaScript, as far as my understanding goes. So in P5, it is used as a 3D renderer. So we can start to build interactive objects. And I know some students were really interested in building 3D for websites and things like that. So I wanted to get more into it so that I could help y'all out with it a little bit more and help y'all understand the way that 3D functions a little bit better. So today we're going to make interactive 3D objects. So let's do a little bit of talk a little bit about how we think in 3D as opposed to 2D. So there's a couple of different things. So when you are working with objects in P5 and elsewhere, 3D objects are made of vertices, which are like points, and then the vertices create subdivisions. So if there's like 3 points, it's a collection that creates a subdivision. And if there's less subdivisions, there's less vertex count, which means the object becomes a little bit more simplified. And the more subdivisions you have, the more like seamless a sphere will become. And it also takes more rendering time, so be aware of that, especially in things like Blender and Unity when we play with those. Okay, so another thing that WebGL in P5 is going to do is it's going to create a z-axis. So up until now we've been working with the x-axis and the y-axis, and it's been pretty simple. But now we're adding depth with that z-axis. So now we have to imagine that things can go, far away from us and come closer to us. The objects will use 3 main things, and we'll only talk about a couple of those things today. But one of them is, instead of using the fill function, we'll start to use materials and in the future shaders. And in order to see the space that we're building or whatever, we have to use lights. So we'll look at lights. And also there's a camera function. So you can move the camera around and play with that. We won't do that today, but that's a lesson for another day. I want y'all to be aware that it exists though. So if we go over into the references, and let's just go to reference here. You can click on 3D, and here you can see all of the lights that you could choose from. So ambient light, specular color, directional light, point light, spotlight, no lights, and the materials. So you can load a shader, create a shader, use textures, ambient material, emissive material, specular material, shininess, and all of that. Today we are simply going to look at ambient light and directional light, and then we're going to look at ambient material, I believe. Yeah, I'm going to try to keep it simple. Okay, and then if you go up here, we've got 3D primitives, so plane, box, sphere, cylinder, and all of that. Today we're going to look at the box, sphere, and the torus. So cool, let's just jump in now. So WebGL. So first thing we want to do to make WebGL happen is in the create canvas function on the third parameter, we're gonna just type that in, WebGL in all caps, and you can see it highlights in pink, which means you can come over here and take a look and see what it is all about here. And then let's do window like we normally do. Window inner width, window inner height to scale it to whatever desktop or like monitor you're viewing it on. Let's do color mode HSB like we're used to. This is a Sydney preference, so to each their own there. And then let's create a sphere. So the parameter that the sphere will include is the radius. So if you just put 1, it'll just look at the radius. But if you put, like, so we'll go here and check out the sphere. So you could put 2 more parameters, detail X and detail Y. These are for the subdivisions, which we're not going to mess with today. But just so you know, like, you can make a sphere look like this by changing the subdivisions. So the more subdivisions, the more spherical, the less subdivisions, the less spherical, but you can customize your shape. So that's cool. So yeah, so today we're just gonna do, just mess with the radius. So we're gonna do that width times 0.2. We know to make things scalable in the beginning so that we don't have to go and change things around later on, right? 0.1, yeah. So this is probably pretty similar to like 100 or maybe less, but the point of it being scalable, if we recall, is that it'll change based on the width of the canvas. Cool, so now here you can see the subdivisions because there's a stroke that's applied, and you could get rid of this by doing no stroke, and you can change the width and color of it. See, it disappears because the sphere is white, so we're just gonna keep that on for right now. Boom. So let's put in ambient material of a white ambient material on here. So we'll do hue can be whatever. We'll just do 0, saturation of 0 for white, and brightness of 100. So that's going to be a white material. And why did it turn black? Well, it turned black because there is currently a white material on it, but because we're in the 3D mode, WebGL, we can't see it because there's no light in the room. And let's just go ahead and change this background color to something else. Let's go ahead and give it some light so that we can see it. Always trying to like label where things are. So because there's an ambient material, it's gonna respond to the ambient light or the directional light or whatever. If you did like a fill, like I'll replace this with fill later. Fill will not, it'll like color your object, but it's not gonna respond to light. So let's just put a fill in here real quick just to see. See, it's white. So you'd think it would work, but it won't, because whenever we put directional lights on it and ambient light, the light won't show up on the fill. So let's undo that. So ambient light. And we're gonna make our ambient light, I wanna make it into a variable because I want it to change. So I'm gonna create a light C variable. So that's gonna be our changing light. So the only way that I'm gonna color my objects here are using light. I'm just gonna put white materials and change the light. So up in the global variables, we'll create let's light C equal 0 as a starting point, so light color. And then, as we recall in previous lessons, in order to get that color changing, anything that changes needs to be in the draw function, and it needs to be a variable, so we created the light C variable, and now we're just going to do that. Plus equals 1, like we know how to do, and now we've got that changing light. Beautiful. So let's do like a 0.1 for like a slow shift, or even 0.5. All right, and if we recall, the light will increase until it goes around the color wheel. So in order to make it cycle around that color wheel, we just need to do a light C equals light C modulo 360. So now we're gonna have like a cycling colors on this sphere, and that's cool. So let's take off this stroke real quick, just see what happens. Yeah, so now it looks like there's a circle. So what's the point of making it in 3D? Well, let's show off its three-dimensional qualities using a directional light. So directional light is a 6-parameter function, and so it'll do like HSB if you're using HSB, or RGB if you're using RGB. So parameter 1 is hue, parameter 2 is saturation, parameter 3 is brightness, parameter 4 is the X direction, parameter 5 is the Y direction, and parameter Z is the Z direction of the way that the light is pointing. So for instance, let's fill these in. The hue, we want the directional light to be our variable of light C because I want it to change, but I don't want it to be the same as the ambient light. So I'm going to do an offset of 100 here, so it'll be a little bit different. And then our second parameter is going to be hue, so we're just going to make hue and brightness 100 and 100. And so now this X, Y, Z. So these three parameters are incremented from 0 to 1. It's not going to read a 2, a 3, and things like that. And so if you, on the x-axis, so let's put, if you want it to, say, point from the left side of your canvas into the sphere that's on the right, then its x needs to be 1, so like positive, needs to be moving in a positive direction. And the y will be 0, and the z will be 0. So that is going to move, it's going to be pointing from the left, as we can see now. So now we've got some elements of our 3D coming in. And if we want it to point from the right, then we just need to make that a -1 because it's shooting backwards. So now it's pointing from the right. If we want to point it up, we need to change that to 0 and change the y. So if we wanted to go up, so we look at our grid, we're moving in the negative y direction, we need to change that to -1. Right? So you get the idea. So I kind of want it to go from the left, and I want to change it to move the light closer to me on the z-axis. So that is going to be, I think, a -1. Let's see. Yeah, because I'm moving it closer to me. Positive would be that direction. So cool. So I want it to actually move a little bit farther this way on the z-axis, positive. So there we go. Okay. So now we have our directional light. And I chose directional light because it's a little bit more of a fill or a flood light than the spotlight, which is like really hard. So I like it, and I like the way it shifts color and things like that. So let's save that. And then, so what we could do is, I just want to show y'all this real quick. We could put a plane, and the plane, I believe you're choosing the, let me see, the X and, what are the parameters? Width and height parameters. So we'll just do 100, 100. I would make it scalable if I were keeping it, but I'm not going to. So see, it's back there. And then you could do the rotate Y function. There's rotate X, rotate Y, and rotate Z, which we'll play a little bit more with in a little bit. But the rotate Y, and then, so if we go to over here, check out rotate X. Rotate X, the parameter is an angle, so the angle of the rotation. And then let's go ahead and use the translate to move it down on the Y. So we're not going to translate on the X, so we got to put a 0. We're going to move it down on the Y, so let's do -200 and see what happens. And then keep it at 0 on the Z. Oops, psych. Down means up. Down means positive. Okay, cool. So there's like a little ground, and you can go and you can like build a scene or whatever. But for our purposes today, we're not going to do that. So we've got our sphere. Let's give it a stroke again, because I like the way that looks. And also I want to play with the rotation, so I need to see the stroke. So we're going to do a light C on the stroke and offset it by 200. And make sure you put the saturation and the brightness. And then I want it to rotate based on my mouse X. So I want this object to be interactive. So in order for it to rotate, change rotation, I need to create another variable. So let R equals 0 for rotation. And then we'll move R, so R plus equals 1. And then in our sphere, we will include the rotate function. And all of this is just review. So rotate uses radians or pi. And then, so we'll put in that R variable. So this is all stuff that we've learned in previous lessons. And so now we can see it rotating here. So that's nice. We could also do rotate X, I believe, and tried that R. So let's try that, see if it does the same thing. Whoa, really fast. Yeah, okay, so if you do like the rotate X, your radians R. Cool, change the rate of the rotation instead of it, just rotating all on its own. Let's change that to mouse X so that it doesn't move until we Oh, I see. Oh, the reason why it's increasing speed, that was confusing me, but is kind of a cool effect. But we just need to do R equals mouse X. So now, like whenever I don't move the mouse, it'll stop. So that's more of what I want. Yes, so now it is rotating only when my mouse is playing with it. Cool. So yeah, you can see if you put in like in future iterations, or like probably for like the next thing that we would do is we would we'll use my scanner, my pop scanner, and in class you could bring an art piece or a product or an object that you want to scan, and make it sure it's like kind of small, reasonable sized. And could be a little bit bigger, it's up to you. And we'll scan it, and we'll create an OBJ, and we will get a JPEG so that we can create a texture for it, and we'll import the OBJ. But let's continue on with this lesson here. And let's go ahead and create because I want this to move. So let's make an X, where is it? There we go. X, Y, Z, or yeah, for the circle. And then let's do, because we're gonna make three objects. So we'll do X1, or Y1, Z1. And then let's do equal, and this is all review. So we want it to like animate using the sine and cosine functions. I'm not going to review this in detail. I'm just going to go ahead and write it, and hopefully y'all have watched previous videos, and if you haven't, just look up the animation videos that I've made, and the sine cosine. I think the sine cosine one is with noise actually, not the animation, but you can find it on my YouTube channel. So sine, we need to use those radians again, and we'll use angle because we don't want it to be the same as our R here. So yeah, let's use angle function. So these are our variables. So these are variables that we still need to go up and create. And if you'll recall, we do need to scale this number up. Times width times 0.05. Cool. So let's copy that. Copy. And paste and paste. And the Y will change to cosine. And the Z, we will make it scale it by a little bit more. Sphere location, okay? And let's just go ahead, since we're already here, let's create another one, and two more. So copy and paste two more. And we're gonna create a torus location, and we're going to create a box location. Okay, so with the torus, let's change the Z to less. So I know what these numbers are because I've already done this, or I created this sketch prior to showing it to you. So I know this is what I want, but I did tweak it a bit to figure it out. And then for the box location, which we'll do last, let's just go ahead, and since we're already here, to save time, let's just, I want it to like go around the, I want it to go like around everything. So we'll just go ahead and do that. Okay, so this needs to be changed to, all of these variables are currently called the same thing. So we need to go ahead and change them, right? Okay, and then we need to create them. So let x1, and we recall we can do this all in one line, x2, x3, let y1, y2, and y3, right? So there's all for the location, all to change and animate. In order, oh, something that I didn't mention as well is like, you would recall whenever we put in the circle function, you have to have like the x parameter, y parameter, and then the size, right? And for the sphere, we just put the radius, we just put the size. And so that's because when you put in an object, you're using WEBGL, everything's going to shift, and like especially if you put in WebGL after you've already created like some code that you made in 2D, everything's going to move around because now the origin is in the middle of the canvas instead of at 0, 0. And in order to move it around the canvas, the sphere, we have to use the translate function, and we're going to put the translate. I want to rotate first, and then I want to translate after. So I'm going to put the translate after the rotate. So let's translate it on the x1, y1, and z1. Actually, I need to move the translate above the rotate. Yeah. Angle is not defined. Oh yeah, haha. Cool, so that's what's good about notes. So I forgot to, here I'm using angle, so I need to just go ahead and create angle. So let angle equal 0, so that's for the cosine. So down here in animate, we need to move the angle, so plus equals 1. Cool, so there we go. Now we've got it moving. And then now we can turn it. Let's just do like one more quick thing, just to make something that looks kind of cool. And we will create a box. And so we're just going to like copy that, and we're gonna paste it. And instead of sphere, we'll put box, right? And the box, if you come over to the reference box, yeah, you're looking at the width, height, and depth. If you just put the 1, it'll do all 3. So for the box, let's just make it a bit bigger. So there we are. Let's ignore the sphere for a second. Okay. And instead of using rotate, we're going to use rotate x, and radians, angle, create an angle variable that is equal to 0. And then we want to move the angle, so angle. So we're moving the rotation and we're moving the light. Cool. And so now that should be moving on the on the x-axis. And then if it's moving on the y-axis, it'll also go that way. So let's copy that, paste and paste, and we're going to change that to a y and this to a z. And it's going to rotate on all angles. Ooh, pretty cool, pretty cool. I want the size to change here, so I'm going to change this to a variable of s, which I then need to come up here and create. So let s equals width times 0.01. Can't be up in the global area. So yeah, so here it's starting like really tiny. And then if we do s plus equals 1, it'll grow in size and it'll just continue to grow forever and ever and ever. If s is greater than or equal to height, or let's do, if s is greater than or equal to width, so if it hits the width, or, as we recall, that's how you say or, s is greater than or equal to height, then let's expand so much it's that big. We want s to equal negative s. So once it hits the edge of the canvas, it goes, and it's small. It goes small again. Boom. So let's multiply this by like 0.3 and multiply that by 0.3 because I don't want it to get so big. Okay, cool. So now we've got this rotating cube that's pretty fun, and I just want to take out the background and show y'all what happens with that. So since we've got this cool, or since we've got the stroke on, it still, the background is, the stroke is drawing like a tracing effect on the background. Okay, so now that we've made a thing, I just want to show off really quickly my website and go to the portfolio and the creative. So this is a work in progress, but I wanted to see if this would work. So I uploaded a little plugin that works with WordPress for P5, and incorporated that code into my website. You could also do this really cool thing that I tried where I did prompted WEBGL, and I said translate the following p5.js code into processing code, because processing is an application that uses Java, and it is a desktop, like it's like a local app, so you aren't going to be like tethered to the website of P5 here, and you could create like full screen interactive projections. So whenever I go and I think, oh, I want to make an interactive projection, I actually use processing instead of P5. So so yeah, I translated the code here. This is what it spit back at me. So since I've worked with processing before, it was pretty easy to just copy this, and what I did was I just pasted it, and when I did, it didn't do it perfectly. I had to change some things, like I had to add some parameters here, and there was a couple things that it didn't get, but for the most part, it actually translated it really well because it's such a simple script. So here I can do the full screen mode and press run, and voila, we see it. Oh, I added a little bit more, but we see it on a full screen, taking up all the space. There's no menus or anything that is making the project ugly. And so yeah, you could do that if you want, and that's something that I am happy to share knowledge in as well. Thank you for watching, and have a nice summer or winter, or whenever you're watching this. Have a nice season.